Today, we stitch simple events together using union and intersection, learn the two big rules, additive and multiplicative, and introduce conditional probability. If any of the outcomes in the union occurs, it means at least one of the two events happened. For example, if you roll a 2, then E occurred, so one can say either E or F has occurred. If you roll a 5, the outcome is in F greater than 3, so again the union also occurred. If you roll a 6, the outcome is in both E and F, the union still occurred. Plus now the intersection occurred because 6 is both even and greater than 3. Venn diagram thinking prevents double counting. Subtract the overlap, or you're counting it twice, like a date where each pays for what they ate alone and both pay for the shared fries. Mutually exclusive means if one event occurred, the other certainly didn't. If the pick is blue, then it's for sure not purple. Many things are mutually exclusive in life, like saying, "I'll be brief," and opening a PowerPoint, or saying, "just one episode," and going to bed before midnight. Complements are mutually exclusive, and combined they cover all the possibilities. So if one event didn't occur, the complementary event certainly did. For example, if you are drawing colored balls and blue didn't occur, then not blue certainly did. They're also a speed hack. Compute the easy opposite, then subtract from 1. This visibly shows how new information, some greater than or equal to 10, reshapes the space of possibilities and changes the probability a lot. Given that is probability with context. We update our view about what is possible after new info arrives. Sequential draws is a common theme of probability problems. The second probability always depends on what happened first, unless you draw with replacement. In that case, the probability of ace remains 4/52 every time. Note that E1 and E2 are complementary events, because they are mutually exclusive and their union is the entire sample space. This is known as a partition of the sample space. You can generalize this rule to an n-event partition using a Venn diagram. Quick compare and contrast saves common mistakes. Disjoint means can't both happen in one repetition of the experiment. Independent means don't influence each other. Independent events are such that knowing one happened does not change your idea about the likelihood of the other. Sequential draws with replacement are independent. For example, if you are drawing from a deck of cards with replacement, the probability of ace at second draw is 4/52, regardless of what happened in the first draw. Pattern to spot. Fixed number of repetitions of a Bernoulli experiment, independent, same probability of success. Count successes and you have a binomial random variable. X could be anywhere between 0 and n. The formula gives you the probability of each possible value of X.